Assalamualaikum and hello. We are from Group 4. We'll present about weather forecasting using Arduino-based CubeSat.
So this is our group member, FARIHAH MULIANIS, me, FATHIN AYUNI, Hana NADHIRAH, ZAFIRAH and AINA ZAMILAH.
Introduction. Measurement instruments have become miniature, efficient, reliable, and more accurate to offer instant weather report without the use of any power. This standard ensures that product meet certain quality requirement, which can help to protect consumers and ensure fair trade practice. The measurement system can also be a design monetary function. It can be used to monitor function by tracking change in physical quantities over time.
I'm FARIHAH, the physical variable. Absolute temperature and humidity are three of the most important variables that have an effect on the atmospheric condition. All these parameters are subject to change with the change of altitude, deadlines, environmental component, sun angle at particular spot, and others. In the modern system of weather forecasting, the environmental data are sent to a computer-based system through a data acquisition system (DAT). Multiple parameters are multiplied before going through one channel and being sent to the computer to display the data. This is the diagram. Here an Arduino Uno is used. Powered by a 9-volt battery and programmed for specific application using Arduino Uno open source software. The temperature and humidity sensor DHT11 is connected to Arduino Uno. DHT11 collects environmental data and sends it to the Arduino Uno for digital processing analysis of data. The connection of BMP 085 to the Arduino Uno is done as follow. The connection of the accelerometer to the Arduino Uno is done as follow: X to A1, Y to A2, Z to A3, pin 5 to pin 5, supply, and GND to GND.
There are three types of sensor. First, DHT11. DHT11 is a digital sensor that collects temperature and humidity data from your surrounding. Second, pressure sensor, BMP085. BMP085 is basically used when you want to accurately measure atmospheric pressure and temperature. Third, accelerometer, ADSL335. An accelerometer is a device that measures a structural motion, acceleration, or vibration. Signal processing. The certain microcontroller cannot read value from analog data unless it is digital data. ADC convert analog signal to digital signal in a certain order. The Arduino microcontroller may process the data further once the analog sensor value has been transformed into a digital value. Further computation and data filtering can be included to obtain useful weather-related information.
The process weather forecasting signal can be represented in a variety of ways. First, graphical visualization may be used to show the signal. Charts, graphs, and plots can all be used to graphically represent the process weather data. For instance, line graph may be used to depict temperature patterns, bar charts can show rainfall levels, and compass-like displays can show wind direction and speed. Onboard displays, ground station software, mobile apps, and online interfaces can all use graphical interfaces. Second, the current values of temperature, humidity, pressure, or other weather factors can be shown using process weather data. It is shown as numeric readouts. Small LCD panels, LED display, text-based information on computer screens, and mobile applications may all display these readouts. Thirdly, the spatial variations in meteorological factors may be shown using heat maps. A heat map might, for instance, display temperature fluctuation over a region or highlight places with heavy precipitation. On computer displays or on mobile devices, Heat maps show weather trends visually. Finally, color-coded alert or warnings can be triggered using processed weather data. For instance, the display can change color to indicate how terrible circumstances are if particular weather conditions, such as extremely high temperature or strong storms reach to a critical threshold. For weather forecasting, firstly, the Arduino microcontroller's analog input pins are linked to the analog sensors used in forecasting, such as temperature, humidity, and pressure sensors. The output signals from these sensors frequently change in voltage or currents according to the parameter being measured. For purpose of comparing the sensor signals, the ADC needs a reference voltage. ADC functionally included in the Arduino microcontroller transformed continuous analog signals from sensors into discrete digital values. The ADC's resolution detects how many digital steps or levels it can represent. More exact measurements are possible with the higher resolutions. By receiving the voltage or current value from the sensor linked to the designated analog input pin, the microcontroller starts the analog to digital conversion process.
Next, we have material. A weather station is a facility either on land or sea with instrument and equipment for measuring atmospheric conditions, to provide information for weather forecast, to study weather and climate. And then here we have table 1, bill of material for weather forecasting. First, we have temperature and humidity sensor, DHT11. And then we have pressure sensor, BMP085. Accelerometer ADXL335, Arduino Uno, monitoring device, RF transmitter and receive module, gas balloon and battery 9 volt. And then we have application. First, we apply it to severe weather alert and advisory. The National Weather Service's issuance of severe weather alert and advisories in the event that dangerous to severe weather is anticipated constitutes a significant portion of modern weather forecasting. Next, we can apply it to air traffic control since the aviation industry is particularly susceptible of weather. Accurate weather forecasting is crucial given that a greater percentage of plane crash that have been reported globally have weather related. Other than that, we can apply it to marine. The use of waterway for commercial and recreational purpose can be severely constrained by the wind direction and speed, wave height and periodicity, tides and precipitation. And lastly, we have agriculture. Farmers rely on weather prediction to determine what tasks to complete each day.
As conclusion, a CubeSat-based weather monitoring system is designed and implemented. The system is simple to construct, portable, cost-efficient, less power-consuming, and reliable. The hardware design and the data acquisition system are demonstrated. These are certain restrictions, such as the device inability to communicate over great distance without strong transceiver, and the potential difficult in recording data at greater altitudes using a gas balloon.